This is Climate Watch. I'm Zhao Ying. Welcome to the show. Our planet is facing a record-high energy imbalance. That's the message from a recent report by the World Meteorological Organization. The UN body confirms that the period between 2015 and 2025 were the hottest years on record. But the temperatures we feel are only a small part of the story. In fact, the air around us holds just about 1% of the excess heat building up in the Earth's system. More than 90% is being absorbed by the oceans, which experienced the highest heat content in history last year. At the same time, melting ice sheets, rising sea levels, and more frequent extreme weather are all signs of a planet moving further out of balance. For the first time, the WMO's State of the Global Climate Report tracks this trend as a key indicator. Put simply, it measures the difference between how much energy our planet receives from the sun and how much it radiates back into space. So what does it really mean for the Earth to be out of balance? How is this affecting our weather, oceans, health, and future generations? Joining us now is Bod Ward, the Policy and Communications Director at the Grantham Research Institute on Climate Change and the Environment. Bob, it's great to have you on our show.
Very good. Good to join you.
So first of all, can you explain a little bit what this energy imbalance of the Earth really means?
Yes, so the energy imbalance is a measure of the extent to which the Earth is warming. The Earth receives energy from the sun in the form of ultraviolet radiation, which has a very short wavelength. When it arrives at the Earth's surface, some of it is reflected straight back from surfaces that are reflective, but most of it is absorbed by the surface of the Earth and then converted into infrared radiation and radiated back into space. And that infrared radiation has a long wavelength. Now, that infrared radiation can then be trapped by the greenhouse gases in the Earth's atmosphere. It's a natural effect. Without the Earth's atmosphere, the surface of the Earth would be about minus 18 degrees Celsius and would be very difficult for life to live here. So it's a natural effect, but because we've been adding greenhouse gases, primarily carbon dioxide, to the atmosphere, it is trapping more and more of the heat. And the imbalance is the amount of energy that arrives on the Earth's surface from the sun, taking away the amount of energy that is radiated away. And that imbalance is the highest it's ever been. What that does mean is that energy has to go somewhere, and the way in which it is being distributed around the Earth is that most of it is being absorbed by the oceans and by the land, and a very small percentage, only about 1% of that energy, warms the atmosphere. And that's the effect of global warming that is well known now.
Okay, but actually it is the first time that this energy imbalance has become a key indicator in the climate report. Why do scientists now feel this is like a more accurate measure of the planet's health than just looking at surface temperature or the daily weather?
Well, if only 1% of the energy is warming the atmosphere, it means that when we measure global surface temperature, we're not really getting a true sense of what's happening here. And the overwhelming majority, more than 90% of the energy, is actually absorbed by the Earth's oceans. And then the heat goes not just into the surface, but deep into the oceans. That heating effect on the oceans is an incredibly important thing for us to be aware of, because what it is doing is storing heat deep inside the oceans. It's raising the temperature of the oceans, but because the oceans are so deep and so large, what it means is that we're increasingly storing large amounts of heat in the oceans, and that heat has to go somewhere, and it's affecting things like the circulation of the oceans, the big circulation patterns which control most of the Earth's weather as well as the currents in the ocean. And we have to be aware that most of the heat that is being absorbed by the Earth is going into the sea waters, the ocean waters, and that's an important reason why they're measuring the fact that this has increased over time over the last 30 years or so.
Yeah, but we know that the Earth has always had its natural climate cycles. Then, how do scientists distinguish between natural energy flows of the planet and the human caused imbalance we are seeing today?
Well, the thing is that we can actually measure the amount of energy entering the atmosphere and the amount of energy that is reflected back from the Earth's surface. We can measure that with satellites. What we can also do is look at over time. You can build a computer model that simulates the Earth's climate and you can test. If you look at all the factors that affect climate, including the amount of energy coming in from the sun, the only thing that explains the warming of the Earth's surface that is we've seen now since industrialization in the 18th and 19th century, the only thing that can explain the warming is greenhouse gases increasing in concentration in the atmosphere. You cannot get the warming trend just by changing other factors like the amount of energy coming from the sun. The amount of energy from the sun does vary over time. You get these solar cycles. But for instance, since the 1980s, the amount of energy from the sun has actually been declining. And so if it was not the greenhouse gases, we would actually be seeing a reduction in the amount of energy arriving from the sun and therefore a cooling of the Earth's surface. In fact, what we've seen is an increase in the temperature of the Earth's surface, which is caused by an increase in the amount of greenhouse gases in the atmosphere that traps the heat.
Okay. So, as you just now said, actually over 90% of that excess heat is going into the oceans, which have absorbed the equivalent of about 18 times annual human energy use each year for the past 2 decades, according to this report. So, to
Yes.
help our listeners visualize this scale, if the ocean stopped absorbing this heat and released it back into the atmosphere, what would happen to the air temperature we actually feel?
Well, if only 1% of the energy has caused the warming we've seen so far, and the warming we've seen since pre-industrialization is equivalent to 1.43 Celsius degrees, which doesn't sound much on a day-to-day basis, changes in daily temperature in any particular place, but that's the global average. The difference between the global average temperature today and the global average temperature in the middle of the ice age, when much of the northern and southern hemispheres were covered by ice sheets, is only about 5 degrees. That's all there is. If all the energy that's going into the ocean at the moment instead went into the atmosphere, you would raise temperature by tens of degrees Celsius. You would probably kill off most life on Earth. So we should be very grateful that that energy is not going into the atmosphere, is going into the oceans. But that's not to say it's not causing problems. It is causing problems. It's causing problems in the oceans. It's transforming, disrupting the ocean circulation, but it's also storing up heat over time, which is then exchanged with the atmosphere. And it means that we're locking in a lot of the warming effect as well that we have been seeing we are experiencing as a result of the greenhouse gases, and means that it will take probably a long time if we eventually stop the amount of greenhouse gas emissions, which is what we need to do if we want to stop climate change. We would have a long period when the world would need to adjust and the heat from the oceans would have to be released, giving us a long period when that release of heat from the oceans would carry on even after we've started emitting greenhouse gases.
So it sounds like the ocean is really like a buffer that protects us on land. But could this buffer also be reaching its limit? And what could be the consequences of that?
So the oceans are acting as a buffer in two ways. First, it's acting as a buffer by absorbing a lot of heat, but I'll come back to that issue. But it's also acting as a buffer because it absorbs a large amount of the carbon dioxide that we're emitting. Now, that carbon dioxide, if it was in the atmosphere, would increase the amount of heating, but a large amount of the carbon dioxide is being absorbed by ocean waters. Now, unfortunately, that means that the ocean waters are becoming slightly more acidic over time, and that's causing problems. That causes a problem, for instance, for marine life that have shells made of calcium carbonate, makes it more difficult for them to construct their shells. But the heat is periodically being released, and it does mean that we are seeing in the pattern of temperature from the that we're recording in the atmosphere, that we get these periods of rapid warming when the temperature rises much more quickly than the underlying trend. And that warming effect is release of some of the heat from the ocean. It also is important to note that tropical cyclones, which form over the oceans in the tropics, are primarily driven by the temperature of the sea surface waters. And if you've got warm sea surface waters, they are driving stronger tropical cyclones. And so over time, we would expect that trend. And indeed, we're seeing that in some parts of the world. For instance, in the North Atlantic, there's now a trend where hurricanes, which are tropical cyclones, are now often becoming very intense very quickly before they hit landfall. And we saw that with the hurricane that hit Jamaica last summer.
Yeah, and apart from the ocean, about 3% of excess energy goes into melting ice. And we see that Antarctica, Greenland, and glaciers around the world are losing significant mass. How soon will these changes affect our weather, ocean circulation, and human societies?
Well, I'm afraid it's already affecting us because sea level is rising. When there are three effects from the on sea level that are happening at the moment. The first is that the warming of the oceans, when you warm water, it expands. It undergoes something called thermal expansion. And that expansion of the ocean waters means that sea level goes up. But we're also adding the amount of water that's in the ocean because we're melting glaciers, and those glaciers are on land. And when they melt, they drain out through rivers and into the oceans. But we're also getting a melting of the major ice sheets in the polar regions in Antarctica and around the Arctic. Um, Sea ice that's floating on the sea when it's melt doesn't change sea level, a bit like an ice cube floating in a glass of water. But if you're adding water that was on land, then that does increase sea level. And it's important to recognize that West Antarctica and Greenland, which are both now starting to become destabilized because of the warming, hold enough ice to raise sea level globally by about 13 meters. Now, that wouldn't happen overnight, but that shows you the scale of the changes that we might be experiencing. And there's already some evidence that parts of Greenland and West Antarctica have become destabilized, that the ice shelves around the outside of these ice sheets are disintegrating, allowing the very large ice sheets to start flowing into the oceans, which itself is raising sea level. So we should be aware that's already happening. But there are even greater dangers that if the great glaciers in the Himalayas melt and eventually disappear, that is the water supply for the Asia's great rivers. And if you kill the source of Asia's great rivers, you will have dramatic impacts on large populations in India and China and elsewhere in Asia. So that's a very important effect that is beginning to happen and one that we should be very aware of.
Yeah, and it could happen like in the future for many, many years because the IPCC says ocean warming and sea level rise will continue for centuries and that changes in ocean pH and deep sea warming are irreversible on a millennial scale. So, what does irreversible really mean in this context, and why are these timescales so long?
Yes, so it's important to note that if we stopped emitting all greenhouse gases tomorrow, that the temperature in the atmosphere would probably stop rising pretty quickly afterwards, um, because you would essentially reduce the amount of energy additional energy that was going into the atmosphere. But the amount of energy that's already in the oceans means that it would continue to be held in the ocean for many, many years, probably hundreds of years afterwards. And as a result, and what is happening is that heat is spreading out throughout the ocean. And as I mentioned, as you warm the water expands and you get sea level rise. And so that effect of the heat spreading out through the oceans, the heat that's already there, would be continuing for many centuries, and therefore sea level rise would continue. So essentially, even if you stop emitting greenhouse gases, which are the driver, you would not reverse the effect. In fact, stopping greenhouse gases just stops the increase in warming in the atmosphere, but sea level rise would continue, the heat would continue to distribute into the ocean. And in effect, even if you were then to reduce the atmosphere temperature, you still wouldn't be reversing the increase in the heat content of the oceans, which will take many centuries before that heat would eventually dissipate. And that's why effectively these effects on human timescales are irreversible.
Okay, but it's still possible to slow down this process, I guess.
Well, it's essential that we just stop it, because there are limits to how much we can cope with. And if we continue on our current path, we could see, for instance, a rise in atmospheric temperatures by the end of this century that would be about 3 degrees higher than they were in pre-industrial. And we haven't seen temperatures like that on the surface of the Earth for about 3 million years, long before humans first appeared about 250,000 years ago. And 3 million years ago, when temperatures were about 3 degrees higher than pre-industrial, global sea level was 5 to 25 meters higher than today, and the polar ice caps were much smaller. So that's where we're headed if we do not stop emitting carbon dioxide and other greenhouse gases. A world that would be transformed, and it would be very, very difficult for us to adapt to that. We will probably kill hundreds of millions of people who just simply will not be able to cope with the rise in sea level and the changes in temperature and other climatic effects.
Okay, and also this report links climate change to the rise of diseases like dengue. How is a warming planet reshaping the geography of disease?
Yes, the way in which diseases are affected by warming is that it affects the climate. And many of these diseases are carried by insects, that you get these diseases like dengue and things like malaria. They're carried by insects, and the places in which those insects are found are affected by temperature and water. And so, as the world is warming, what you're doing is changing the geographic distribution of those insects that carry these diseases. And that's why we're seeing an increase in some of these diseases as a result of climate change.
Yeah, and the report says over 1.2 billion workers are facing extreme heat risks. So, are we approaching a point where parts of the world could become economically unviable due to climate driven productivity loss?
The human body cools itself naturally through sweating. And what happens is you produce sweat onto the surface of your skin and it evaporates. And in evaporating, what it's doing is taking heat away from your skin and causing you to cool down. Now, that evaporation process cannot happen if the atmosphere is too warm and too humid. And if you have the equivalent of a temperature of 35 degrees and 100% humidity, you will find that you cannot cool yourself anymore. Now, if you get at higher temperatures and lower humidities, you'll still get that effect. And so it becomes dangerous. You can die because your body overheats. And we're now rapidly approaching that potential position in many parts of the world where it would be dangerous to be outside in those kinds of temperature and will affect people who particularly who work outside. That includes people who work farmers who work in fields, but also construction workers. And so many parts of the world are going to become impossible for you to work in during the peak days. And that also will have a massive effect on the world's economies as well as threatening the health of workers.
Yeah, and I guess that's why the report talks about cascading impacts. For example, drought leading to food insecurity and then displacement. Do you think we're already seeing these cascading effects play out in real world conflicts or instability?
Yeah, we're certainly seeing the effects of extreme weather causing displacement of populations, and that's a trend that's going to continue. If you have things like drought that wipe out crops and kill livestock, then you essentially wipe out the food stocks for populations and people move. We've seen that throughout history. You can get famines where essentially people are starving to death and they move to escape the effects. And so the increasing impact of climate change, where sea levels are rising and tropical storms will wipe out coastal communities, where increasing droughts wipe out crops, where flooding along rivers wipe out river defenses and flood villages. All those effects make lives more difficult, create political instability, and create reasons why people want to move. And when people move, on a large scale, we know that that also causes conflict and war. So a world of increasing climate change impacts is not a one of peace and prosperity. It's a place of war and poverty, and that's why we have to stop climate change.
Okay. And also, the report suggests only half of the world's countries have heat early warning systems tailored for health. And I guess the other half includes the most vulnerable population in the global south. So, how important is it to close this observation gap?
You're quite right that most of the world that is affected by heat is in around the tropics where temperatures are highest, and they're often countries that are poorest and less able to afford things like air conditioning that can protect you against heat. Now, you can only protect yourself against heat if you know it's coming, and that requires you to have sophisticated weather models. And again, they are less likely to occur in the poorest countries. So it's absolutely essential that we share the technology and the ability to make long-term weather forecasts. And it doesn't just apply to heat, it applies to tropical storms as well. You need to be able to warn people that tropical cyclones are approaching so that they can evacuate and move to higher ground and safety. We need to be better at warning people about extreme weather events when we can see that coming. We have the technology, it's just that it's not fairly distributed around the world, and therefore we need a big investment in improving the weather forecasting and analysis of the poorest countries around the world, because it's those countries where people are most vulnerable and exposed to the impacts and where people die and livelihoods are destroyed if they aren't protected.
Yeah, and since you mentioned technology, actually, we know that advances in AI and weather modeling are kind of revolutionizing climate observation. But can these tools help us stay one step ahead of a climate that is increasingly out of balance, or do they just give us a clearer view of an unfolding crisis?
Well, the digital revolution and AI can help us in a couple of ways. The first is that they can help us model a changing climate. We're now in uncharted territory. We're in a climate that we haven't experienced historically. And so it's very difficult for us to be able to work out what is coming to us. We're experiencing temperatures and rainfall that has never been recorded before. AI will help us to model that and help us to understand just how bad things are going to get and give us a chance to try and protect ourselves against the effects of higher rainfall, more intense and frequent heat waves. It can also help us in managing things like our power sector. And if we have a power sector that, for instance, is more draws more electricity from distributed renewable energy like wind and solar, that will be good for us because it will help us reduce our dependence on fossil fuels. And it is the burning of fossil fuels which is the main driver of climate change because it produces carbon dioxide. And the only way we're going to stop climate change is by stopping our consumption of fossil fuels. And that means moving to cleaner technology and having power systems that are better able to deal with distributed variable sources of electricity like wind and solar. That is our only chance because, as I've described, the climate is changing now to such an extent that it's going to be very, very difficult for us to just withstand the effects.
Okay, thank you, Bod Ward, the Policy and Communications Director at the Grantham Research Institute on Climate Change and Environment. Thank you so much for being with us today.
Thank you.
And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cgtn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time. Thank you.